Thank you. So first, I'm going to introduce my journey. Like, my journey into development started 20 years ago already, And, well, it was a very interesting time. For the people who were around at the time in web, we were using HTML and CSS2. That was quite new at the time. Really exciting release. And I was using PHP and testing everything on the marvelous Internet Explorer 6. So, yeah, that was quite a period. So my workflow at the time was very simple. I would mess things around. I would build some kind of website. I would learn something new and start again. Well, feel like, the period of doing that. 10 years ago, Swift was introduced, and I was waiting for an opportunity to start iOS development, so that was the time. I bought a Mac, and I tried that, and I loved it, but at the time, I was really new, and there are so many things I wish I knew, like, well, what happens if I rename an IB outlet var, I get a crash, weird, or, well, why is there all those NS everywhere, and, why is my UI view controller becoming that huge? Because I don't know anything about architecture, obviously, and I won't even mention app delegate. And also, why have I gotten some optional. Oh, Swift 1. So this led me to getting a job, and in 2017, my job that was iOS started to convert into a backend thing only. And that was a good thing, because my workflow was updated. Now I would mess things around, break the prod, learn something new, and start again. Yeah. So back in 2021, I was, doing a backend for quite some time, but I was missing iOS, so I started building iOS app for me. So those are my apps in the App Store today, and feel free to ask me for free stickers that I have around. If you are into stickers things, I have a lot of them. And so this brings me today at ServerSide.swift. Today, I'm going to try to answer a question that I've seen a lot. A lot of people are like, okay, I'm coming for iOS. I know Swift, so I'm going to do my first backend into Swift. And so is what I think you need to know first, because it's not really the same thing to build a backend than building an app. So let's kickstart your journey into the backend world. And it's basically the things I wish I knew when I started doing API and backend. So I'm Thomas Durand. You can call me Dean if you're not into, the French naming thing. You will find me on Mastodon, Thread. I have a blog, and I also have a Twitter account that I don't really use that much now. So I'm backend architect at DailyTrust, which is a legal tech in France. I'm doing iOS indie dev for quite a while now. And I'm also a speaker, tech provider, and really Apple enthusiast, as you can imagine. So, welcome to the backend. So first, let's take a little bit of perspective. You are building an app, and you have, on this app, you have users. Well, if you put the backend into there, you have the API, and your app is using it. So basically, the app is the user for your backend, and your users are using your app. Back to your app. An app is basically a machine that takes all sorts of inputs as touches and whatever the phone have in its sensors, and you get an output. That would be drawings, animation, text inputs, everything you can imagine out of an app. In a sense, the server is the same thing. It takes some inputs in a form most likely to be HTTP request, and it will give an output, most likely to be HTTP responses. So in a sense, backend is simpler. Don't overthink it. That's my point of view. But is it really? So let's get started. In this session, we'll have a look on how to handle incoming requests with your server. We'll see how to approach API evolution. That's a question that I've seen a lot going on the networks. And we'll have a quick word on security concerns you might have. We'll look into how to authenticate your requests properly. And we'll have a word to go from there, because obviously you will have a lot of things to do after that. So let's handle your request. But first, what's a request? A request will look like that if you do it with Foundation. It's pretty messy to explain like that, so I'm going to use HTTP types. HTTP types, it's a library from Apple. It's giving representation of HTTP in a more strongly typed manner. So an HTTP request has some kind of method that is called an HTTP verb, like get, post, and others. And you will have a route aside of the server you want to call that route on. You might have headers on that request that is basically metadata that will complete the request. You can then call that request using Foundation or whatever you want and get some kind of response. Some kind of request, like post requests, they might have a payload. And this is meaning that you are giving the request some content. And that content also have a content type, probably some kind of JSON object. Now, to summarize, a request is just a route, headers, and a payload. Now, let's have a look at the response. The response is pretty much the same thing. You will get some data out that will be the payload of the response. You will get a status if it has worked or not, and you know that already, all right? And you will get the headers, and those are the response headers, not to be messed up with the request headers, and they will contain everything the server feels right to give you as metadata as well. So let's build one. I'm going to use Vapor, that feels like natural for me, and you will have a route function that you can use to add new routes. Cool. So I'm going to add an apps route that will be a get. Just notice that it's pretty obvious of what I'm doing. And then I can just send back my content. So I'm going to send back an array of app. App will be a content that's a protocol exposed by Vapor that make it decodable, more likely, and pretty much other things. And it just works. This is going to expose a get apps route, sending an array of app as whatever you ask for, so likely JSON. This is what we call a route handler. And it looks like this in the responded chain. You get a request, it goes to the handler, and you get a response. Why is it called a chain? Because you can add what we call middleware. A middleware is something that takes the request, can change the request, give that to the next handler, and then it gets the response, can mess with the response, and give that to the previous middleware. You can have as much as middleware you want, so it makes a chain. As responsibility, middleware can do a lot of things. So you can authenticate in a middleware, you can have a cache middleware, you can add security headers to middlewares, and basically middlewares is about bringing separation of concern into how you deal with your request, and also bring reusability of things that you want on multiple requests. You don't want to repeat yourself into your handlers. So we'll see later how to build a middleware, but first, let's discuss about API evolution. So you have an app that you ship, and it works, it's pretty good, and you update it often. And sometimes you might send to the App Store an update that is breaking with a bug. Ooh. So you decide that you need a fix, and you publish very quickly a fixing version that works and that makes everyone happy. And if you're fast enough that you do, I don't know, expedite review and stuff like that, you might make the release that fast that some user will never see the full version. They will update from a working version to another working version, and you're just fine. Now imagine a similar event with a server. You publish the server in your app, you make a new releases, and then you're like, okay, I'm going to do a big update that need to update also a few routes of my server. And you publish that. And you might have broken old apps, because the old apps, they are using API in a way that the server does not work anymore. So you're like, okay, I've broken everything, let's roll back. And now you have your new app that is broken because it's expecting the new server, and you are now handling an app to the new user that are not working. But you can do even worse. You can just ship a backend version that just break it all. Yeah, so that's pretty much something you would like to avoid. how do you avoid this kind of situation? Is that big enough? So you should be writing tests, a lot of tests. And this is what we call functional test. The functional test is a test that is actually going to test your API as a black box. You send a request and you get a response and you test the response. Functional tests are a big deal here, or you would implement it with some code that I introduced that is not part of Vapor, but that's fine. I just want you to focus on the fact that I'm getting the root app, getting the response, and I'm going to decode it using the app object. Therefore, this decoding is using the struct as the server knows it. So it's pretty fine, it's going to decode it, but this is going to test that the server works. But it's not going to test that against your app expectations, because the structure as your app knows it might be a little bit different. So what you should do is that you should introduce tests as the way your app knows them. So it would look like this, like you would pretty much copy and paste the structure the way your app knows it. Here I called it app v1. And you would decode it using that object that would be part of your test. If your app expectation updates, you would introduce a new test with the new object, and that way you would keep every requirement of older apps within your test of your server. And this is important because it will bring confidence to your deployments that you are not breaking all of your app out there as long as you run the test before deploying. But obviously you do that, right? To prevent backward incompatible changes, you can also plan ahead and see what's good for not breaking stuff. So on an existing route that have a pretty simple response, you can afford to maybe add a query parameter that is optional. If it's optional, it means that you can not provide it, and if you cannot provide it, it's retrocompatible. In the same way, you can also add new keys to your response, because this is ignored when you decode things, and so you're basically fine at decoding the whole thing. For requests that take a payload, what you can do is that you can also add optional parameters to your payload. It must be optional, because if it's required, when older apps that might not send it, they will get some kind of error from the server because the key will be missing. And of course, another obvious way of not breaking things up is just to add new routes, because new routes are never been used in the past, so they are retrocompatible by default. Also, to build better responses, just be aware that the format you do your response matters a lot. It's really common to return an array, but I don't feel like it's a good way of doing things. I tend to prefer to return objects instead. It's not a big change in both of terms of bandwidth and other stuff, but it's going to allow you to bring more capabilities to your route, because you will be able to add other properties that will be outside of your object. And that would allow you to transform your route to add other kind of properties, like maybe the count or maybe other interesting information that you might find interesting, like what kind of filter are available, and expose that to your app. To do this kind of thing, you can introduce a container. In Vapor, it would look like that. And using the power of generics, you would be able to reuse that everywhere. Of course, you can also introduce some conformance to protocols that will bring you better API over your content for free, like is empty and stuff like that, and make your life simpler when writing tests, for instance. And with the new code assist stuff, those things were generated automatically for me. I didn't have to bother. Another technique that I'm not really a fan about, but that works, is to send your app version in a custom header in your request. Doing so, you are able to check that version server-side and have slightly different behaviors, meaning that you would be able to keep an older behavior for an app that does not support a new behavior and change a little bit the response or the behavior for your new app. Those kind of code is pretty easy to set up with the proper code that would power it. I'm not going to show the code. Code Assist generated that for me as well, pretty much correctly. So, well, Code Assist is pretty cool. Regarding retrocompatibility and evolution, I wrote a blog post back then that I might update in the upcoming days that you can eventually have a look on. Now, let's see a few security concerns that you might have. I think the most important part in security when you are publishing an API consists of one thing, using TLS. Yet TLS stands from Transport Layer Security. That's pretty much the S on the HTTPS. And it's enforced by all modern systems. It's pretty nasty to try to avoid using TLS. It's possible, but it requires a few things on iOS at least. And I would never recommend it. But what's good about TLS is that it comes from pretty much free, depending on where you store things. But just be aware about that, specifically if you introduce your own domain. So TLS, it runs over port 443. And so it means that your app needs to be available from that port somehow on the internet. Vapor support TLS, meaning that you could deploy Vapor and expose directly the port into Vapor. But that's not really the way things work in a modern infrastructure architecture. Generally, you would have some kind of load balancer before and your app after. And the load balancer would be responsible for adding TLS and other related headers to your responses, and your app would run aside on a private network. This allows to get your app horizontally scalable, and it matters if you have a lot of traffic, so just keep that in mind. Then, for security, ensure that you get response headers right. So response headers, they are basically saying what you should and should not do with the request. They are a pretty big deal for browsers, way less a big deal for native applications that don't really need them. But if you plan to use your request on a web application, make sure to have your response header perfectly right. There is this really good package that does the heavy lifting for you. And if you are responsible for TLS within your app, don't forget about the HSTS header, that is a strict transport security one. But this should be added by your load balancer that is actually making the TLS, in my opinion. And then test it. There are a lot of services out there that are going to make tests on how strong are your request headers, how strong are your TLS configuration, and give you proper information about what you should improve in your configuration. Regarding headers, like I said, some of them might not be useful, but it doesn't cost that much bandwidth to include everything correctly, even if you don't really need them. And my final advice, but this one is the same for every kind of thing you are going to build out there, you should validate user input. You do that in your client side. It's even more important to do that on the server side. The server is the latest frontier for preventing anyone to mess up. And people will be able to inject whatever request they want, even not going through to your app. So your server should validate everything, should ensure that you are authorized to do anything. And it should never, ever send a user input directly into the database. You should always sanitize that to ensure that you prevent yourself from injection. Now, let's discuss a little bit about authentication and what it means. So remember the request and response flow that we had on the server? We would just add some kind of secret to the request. And know that we have a secret in the request. This is what we call an authenticated request. You'd have to own the secrets so that you prove who you are and that you get access. And if you don't have this secret, or if it's wrong, you don't have access and you get a 401 unauthorized. This is pretty much what an authenticated request means. So how do we get that secret? Authenticate. So authentication is the key moment where you get the secret from your server, and it depends. For creating an authentication that works, you need to ask yourself, what am I authenticating? You could be authenticating a user, but you could also be authenticating that it's your app that is actually using your API. So let's start with user. User in the old school, it's pretty much you get a username or email and a password. You send that to the server, and the server will check the password and send you back the secret. Just be sure if you do that, that you do not store the password in plain text in your database, because it means that if someone gets access to your database at some point, it will get every password of everyone, and this is pretty bad, not only for you, but also for every places where your user have reused their password, because sadly, they will do that. You should hash your password. So Vapor explained that pretty much correctly, and so follow the documentation. The idea of a hash is that you cannot go back. You transform the password, you hash it, and then you can just check that the password is matching the hash, but you cannot get the password from the hash. But there is a better way. You don't want to mess up with sending email, validating emails and stuff, so you can use any SSO out there. So let's talk about signing with Apple. Signing with Apple flow is pretty easy. You ask sign in with Apple for a secret, the app gets the secret, you transfer that to the server, and the server will check with Apple server if the secret is right. If everything matches up, you are authenticated, everything works. Now, let's look how we authenticate as an app. So we could imagine that we put a secret in the app that would be like a formal API key, and, well, no. I'm just going to say that's my opinion, but API keys are not meant for client-side. API keys, at least for authenticating something, they are for server-side. So if you want to authenticate your app, you should use something that is made for it. So something like App Attest, that is an API from Apple, and it works pretty much like or sign in with Apple would work. Like the system would provide you some kind of secret that you would forward to your server, and that you would then check with Apple servers if the secret is right. The documentation about that is pretty interesting. I have never implemented it on myself. I will try that later on because I just want to mess up with cryptography, but for now, just look at the documentation if you need that kind of thing. And also ask yourself, do I really need to authenticate my app against my API? If your API costs you a lot of money, maybe you should. So now you don't want to do that for every request. You are not going to ask Apple if the secret is correct for every request. So instead, you are going to introduce an authentication ceremony, like a special endpoint where you will send your secrets and get a secret back. And so the server will generate a secret that he knows about, and so it will prevent you from having to check with the secrets with Apple of other services every time. And then that secret you will reuse in your request and get your response. So what kind of secret do you send back in that case? And the answer could be quite generic, like it should be anything random enough so that it cannot be guessed. There are two approaches that I've seen out there. The first one would be to store the token somehow in the database. And so you would generate it, and you would store it, you would send it back. It would be better to hash it within the database because you don't want, to have an attacker that gets all the tokens that are available right now from the database if they get access to that. And then the application would be able to authenticate by providing back this token within the header of the request. Now, how do we check that token is valid? This is where we are going to introduce a middleware. In Vapor, middleware looks like this. You need to respond to a request, and then you have the chaining to next that allows you to give that the responsibility for next request. So you can do whatever you want with the request, give that to next, get the response, and do whatever you want with the response. For authentication part, we don't need to mess up with you need to use your middleware. If you don't use the middleware, it will not be used by the system. Also, for authentication part, you might not want to use it for every routes, or at least you will need to have an exception for the authentication routes, because if you need to be authenticated to authenticate, you are going to have some kind of problems. So we don't need a response for the authentication. You just need to mess up with the request, and we will get the token from the header, and this will give you this. And then you will have to check it with the database, depending if it's hashed or not, and depending on how you store in the database, it changed. And if it's not correct, you would just throw an abort unauthorized there. But there is a better way that do not require database. Instead, we could use the power of cryptography. And instead of storing things in database and saying this token is associated to that user, you would give all the information in a token, and you would sign that token and give that over to the person. It looked like that in the case of GW2, it's the most widely used out there. And you will see that we have headers that give you algorithm info and stuff that is necessary to check the token. You will have the payload that contains everything required for identifying the user, and you will get the signature. It's the tail part. And this one is ensuring that the integrity of the token. If someone tries to change that, the signature will be wrong. To issue a signed token is very easy, a very cool library also built in Vapor. You just need a secret. So here the secret is hardcode. Please don't do that. Provide that at least from an environment variable, and it would be preferable that this environment variable comes from a vault, but that's the secret. That's the thing that should never leak from your server. From that secret, you will be able to have the payload described, and that payload will then be used to sign a token. And that's it. You have now a token that contains everything. Your server don't even have to store it, and you can just send that to the application. Now, let's check that. Remember that all that code we've made up until there? Well, we just have to reduce because, GWT library will do the heavy lifting for you. And now you have a verification that the JSON Web Token is valid. Yet again, this middleware, if you apply on all of your routes and that you're not opting out your authentication route, it will not really work well. So where do you go from there? We have discussed of a lot of things, but of course, if you want to build a whole backend and API, there are still a lot of topics you can look into. First, I think you will try to use a database because you will want to store data and pull data from there. On Vapor, they use Fluent. That is the equivalent of core data, but for Vapor. It's simpler to use than core data, but it's what we call a DBAL for database abstraction layer, and it's pretty cool to use. Also, you might want to use a key value cache, something that will allow you to store arbitrary data for caching thing. There are a lot of consideration when you use cache, but it's something that you use a lot, specifically when you have things that are a little bit to compute. And also, a big topic that you will have to look into is deployment. I'm really thankful that there are a lot of deployment talk in this event, so make sure to pay attention to those, because the deployment is the thing that will allow you to use your code out there. Having something on localhost is pretty fun, but using it in the real world is even better. So here I have a few resources that you might have for that. Also, if you're stuck, just do what Mikola said. Leverage the community. Ask your question out there. Go on the social networks and just say that it doesn't work for you and that you don't understand a thing. People will come for help. And when you can come up with something that works and that you are happy on how much you have learned, well, share that. Write, do videos, and whatever. It's important that the community find information about what you learn and how you actually manage to make it work. And thank you.